Okay, good afternoon, everyone. It's nice to have so many new ones also participating this afternoon session. We had already the first session in Finnish in the morning, and sorry for those who were also in the morning session that I will partly repeat something that was also discussed then. But first of all, this is about sustainability, one word with many dimensions in agriculture. And it is not anyhow unclear why we have been talking about sustainability for decades. This photo is certainly not from Finland. There has been lots of evolution along with time. And as also in morning session, a couple of times were mentioned, sustainability is often seen as three dimensions. The systems have to be also agricultural systems, environmentally sustainable, economically sustainable, and socially sustainable. Every now and then we can hear about cultural sustainability, which is quite a lot linked to social one, I expect. But then I would say that isn't there something missing if we talk about agriculture per se and sustainability in agriculture? And what I mean with this is that actually there should be also a dimension of productive sustainability. This is issue that we are talking about a lot, and we have lots of efforts going on, for example, in maintaining soil health or improving it. But we don't, or at least very seldom, one can see that productive sustainability is considered as its own dimension of sustainability. And I'd like to highlight it in this presentation. Often you can also hear that something that is environmentally sustainable must be productively sustainable, and economical sustainability might support productive sustainability, but that's not actually the case. There are much more to be included in this dimension as well, and hence it earns to be sustainability dimension of its own when we are at least in the agricultural context. Olympic Games are a very topical issue right now, and one could say that actually this is like a modern sustainability pentathlon, and of course in Finland we are quite eager to be also successful in this type of event and happening. And in this particular presentation, the productive sustainability is quite a lot in a core. And of course, if you look at the program of today, there is plenty of other dimensions also included, from environmentally to economically and also socially and culturally sustainable systems. This was something I said in Finnish in the morning session, and as you can see from the discussion of this seminar or webinar, it has raised some concern because our OPAL-Life land use optimization tool related slogan has been that every field does not have an equal right to be cultivated. And with equal rights, I mean that they should not be considered that always one field parcel is just like perfect for food production, but we really need to consider alternative land use opportunities, and this of course is something that is beyond the basic idea of land use changes and allocation issues. So in Finland, we have very variable field conditions in general. So if we think about land use changes and land use optimization issues, then highly productive fields with many advantageous field characteristics are something that should be kept into sustainable intensification, meaning food production and of course feed production. We need to just take very good care, go on and keep very good care of these, because they are really the essence of the agricultural production, especially food production. Then we have many poorly performing fields with disadvantages. They can serve for extensification activities like different kind of environmental fellows, nature managed fields. They can recover when they are in, for example, perennial, different type of perennial grasslands. They can recover, uh, and they are in any case sort of very important reserve to use for possible future need, for example, to sustain food security in the case that arable land areas are decreasing. Then there is, of course, such poorly performing fields which have plenty of disadvantages, and they don't have high productivity. They have actually high productivity gaps, and these are especially for afforestation or any other greening purposes. And of course, one can consider, as we have been discussed a lot in the morning session, there are many alternative ways how to take care, how to benefit from these field parcels, and for example, in the morning, bioenergy production issues and such were mentioned several times in our discussion. Uh, well, we in this OPAL-Life project, we have launched this land use optimization tool for farmers. It's free of charge decision support system, and it has 3 scoring steps. First, it takes into account the general physical characteristics of the field parcels, and I have to highlight that this is something that is based on large scale uh, field parcel scale assessments, how farmers in Finland actually in true life allocate field parcel to different purposes, food production and feed production, or for greening purposes. According to the scoring, there will be um, uh, 4 different alternative outcomes. Green color is for sustainable intensification. They are very perfect field parcels. Then there are those which have somewhat poor characteristics. Often they are small, they are far away from farm center. These are very much highlighted by the farmers as an important field parcel characteristics. They might be something between those, so not yet decided whether they are good enough or not. And then there is these very poor parcels, which this particular land use optimization tool proposed to be forested already at the very early stages of the scoring process. Then we are estimating this productivity. This is based on satellite images, and we benefit from normalized difference vegetation index values. We take the whole growing season into account, and what you can see here is that we have one field parcel which is of our interest. This is spring wheat, and then we compare it to the regional other spring wheat fields in a quite large surrounding region, and we take best 10% of them and consider that these are the regional best ones, and they don't actually have any yield gap, at least something to mention. And we can see that, for example, here this wheat parcel, it seems to be performing quite nice. So it's very close to be among the best 10%. And the yield cap of actually it's not yield, it's productivity cap because it's based on biomass production capacity, what we are seeing as the NDVI value. So the productivity cap is about 6% it's only. Here is median for all the regional spring wheat parcels. And then there is the worst 1/4. So in that way, we estimate the productivity or actually productivity cap, and based on that there might be changes in the allocation of each single field parcel depending on the productivity. We also consider proximity to waterway, but also only in the sense that if there is some field parcel that still remains to be yellow after productivity assessments, if it's very close to the borderline of being either yellow or red, it turns to be red if it's next to the waterway. And then in the next scoring round, we check the soil type, only in the case if these field parcels that are for extensification and greening purposes or whatever purposes, if they are on peatland, this land use optimization tool proposes to be rather afforested than to go on as a field reserve and so on. So then we have this land allocation action plan for a farmer. And this is just something that gives some ideas to the farmer how to possibly make land use changes, but of course farmer is the one who decides. And this is something that is in our Economy Doctor portal. So in Lucas Economy Doctor portal available for farmers, and one farmer can only see the data from his own field parcels or leased ones, if they are leased in that particular year of assessment. And so this is the tool. The decision support is given for in this way is something for landscape scale changes, and all the time, as I mentioned, the productivity issues there when started with the sustainability term and how to interpret it and how to have different dimensions in it. It's very important that especially in this land use optimization tool, all the major resources are of course allocated to those highly productive fields. There might be some yield caps, but they are very good in many field parcel characteristics, and thereby it's very essential that farmers try to keep these particular parcels all the time in food production and does not let them to go towards extensification, because this is like the primary start point for cultivation in a farm.
Pirjo, 2 minutes.
Yep. Then we have decision support also for diversification. So just switching from landscape scale, which is especially considered with this land use optimization tool to diversify crop rotations. We have developed in one and other project interactive tool to diversify crop rotation. It takes into account for each field parcel the 5 years history, cultivation history, and success as diverse crop rotation as possible. Farmer can make changes during the process, and all the time the impacts on farm economy are considered. This is again something that is fully based on the studies how farmers actually allocate different feed parcels or crops for different or field parcels with different characteristics. So this is again from hundreds of thousands of field parcels this data coming from. And it looks like this as an example. We have more diverse crop rotation, meaning that if here we have as a start point very seldom, you can see here diverse rotations with at least 2 other crops within 5 years than cereals, and the tool proposes something like that. Of course, farmer as an interactive, when it's interactive tool, can also make the changes, but this is how it starts to success. And it really takes into account something like lot sizes and distances, so it does not scatter everything everywhere, but tries to follow farming logistics as much as possible. And then we have also benefited uh, in this tool from pre-crop values that we have got from satellite images. This is again from farmers' fields, some hundreds of thousands or tens of thousands field parcels, and from the true life. And we can see here as an example, spring barley as subsequent crop in rotation, and here are different pre-crops for spring barley. And you can see cereals not so excellent, 2 years for each of the species. But then we can see here, for example, that the special crops looks really nice as pre-crop values for spring barley. And here is the percentage, how much it increases productivity according to normalized difference vegetation index values. So we are developing decision support tools and decision support for cultivation of cover crops as well. We have just started this, so this is going to be our next step in giving some additional tools based on the farmers' own experiences and understanding they have shared with us with one survey with high number of farmers. And you can see that there is already interesting expertise, even though this is only in the start of the process of expanding in Finland. These cover crops used quite a lot earlier, primarily in organic farming. So data intensive times, and one can ask, is there lack of data? Or is there more like plenty of data but lack of understanding, and or is there lack of capacity to benefit from it all? So here is like a spider web indicating that it might be hard to get out of the spider web sometimes because it's so crowded. And just to end my presentation, what I mean with this spider web is that, for example, these tools are based on these scientific papers we have published recently, but there are also almost the same amount of additional ones. So this is something that we have to do, of course, in order to share these issues with scientific society and have approval for our methods and so on. But actually what we like to do in order to implement our results to farmers is having different kind of decision support tools, because we really need to be able to just breed and make the data much more ready for use, direct used by farmers, so otherwise it's more or less lost. Thank you.